Hi guys, it's Miss Sheehan, and I've had a lot of requests for the pipe cleaner proteins to try to help y'all review some of this information with your macromolecules. So if you remember, in class we got our pipe cleaners out, and one single pipe cleaner was like looking at our polypeptide chain. Okay, so this polypeptide chain, if this was our primary structure, this is just a bunch of amino acids strung together, right? So amino acid, amino acid, amino acid, amino acid. You can kind of imagine coming off of there a bunch of little R groups all the way around maybe, but this right here, primary structure, is just amino acids covalently bonded together. Okay, so let's take our primary structure and make a secondary structure. Okay, if we curl it up, our secondary structure, we just got an alpha helix there. We may do some beta pleating, little beta pleated sheet. Okay, once you've got your secondary structure, this is just looking at the backbone, those amines and those carboxyl groups interacting. The hydrogen bonds that take place between them will give you your secondary structures. All right, we're still looking at a single polypeptide. So tertiary structure, if we have R groups, and so tertiary is the first time we start talking about our R groups here and how they're interacting. Our R groups, if we have something that has some type of ionic charge over here, it's positive, something negative over here, those two are going to be drawn up to each other. So we just got a little folding in our tertiary structure. Maybe there's one over here that's very nonpolar, a little nonpolar R group, so it's going to try to fold in toward the middle to try to get away from that watery environment of the cell and of the body. Okay, so whenever you start looking at tertiary structure, you're looking at how the R groups are interacting, and that is going to be looking at your disulfide bridges, which remember are your sulfurs connecting to your sulfurs. You also have hydrogen bonding that's in there, ionic bonding, the hydrophobic interactions. All those are taking place at this tertiary level where it starts folding in on itself. And that's based on the R groups that are present. Okay, from there, every protein will make it to this tertiary level. The next step is if we had multiple polypeptides. Okay, so we had a gold one, now we have a purple one, we got a secondary structure. It's going to start folding in on itself to give us that tertiary structure. Okay, there's another polypeptide. We have our primary structure of amino acids. We just got a little secondary structure here. Okay, tertiary, we're going to let those R groups make it fold in on itself. So quaternary, and you have a lot of proteins that do this, but not all of them will do it. It's if you have multiple polypeptide chains, and then their R groups are all going to interact to give you a protein. Okay, this again is the R groups interacting to make those connections. So primary structure, covalent bonds between amino acids. Secondary structure, hydrogen bonds between your amino acids and carboxylic acids. Amines, not amino acids, I'm sorry. And then tertiary structure is the interaction of those R groups, and that can be in a lot of different ways that those interact. Quaternary, you have multiple polypeptides already in their tertiary structure that will allow their R groups to interact and combine together. And that's it for the pipe cleaner proteins.